Hi, everyone. Good morning, good afternoon, good evening. It's great to have everyone on board. Thank you so much for joining today's webinar. What is next in the long duration energy storage arena? Thank you so much for being here with us today. We have 4 amazing speakers with us, which we will introduce very soon. My name is Christina Galan. I am part of the RenMad team. I will be being the moderator today, and also doing a couple of housekeeping rules. So today's session will be recorded, and we'll be sharing the materials with everyone later on during the week. If you have any questions, please use the Q&A section for our speakers. Let us know what's interesting for you in this topic, and any questions you have for them, please feel free to let them know. And also, let us know, introduce yourselves in the chat. Also, our friends in YouTube, let us know where you're from, what company you are joining, where you're joining from, country, everything. We want to know everything, of course. So let us know. Please use that chat, which is also available for you. So without further ado, we were going to move on with the speakers, introducing them briefly. So by order of appearance. So Omar, whenever you're ready.
Hello, everybody. I am Omar Guerra from NREL. I am research engineer at the Grid Planning and Analysis Center. I have been working at NREL for almost 6 years on the techno-economic analysis of energy storage and hydrogen technologies, with a focus on grid integration of particularly long duration and seasonal energy storage. Thank you very much, Christina.
Thanks, Omar.
Hello,
everyone. Oh, sorry, Chris. I was going to introduce you briefly. Chris, whenever you're ready.
Hello, everyone. My name is Chris Connors. I am a co-founder and principal of Breeze. I've been in renewable energies for about 12 years. Prior to that, I was with Bell Labs, Ernst & Young, and Chase. Thank you very much for the opportunity to speak with you today.
Thank you, Chris, for joining. So we also have Jonas Wallmander from Azelio. Hi, Jonas.
Thank you. Yeah, my name is Jonas Wallmander, and I am the CEO of Azelio. And I've been in renewable energy for almost 20 years. And now the last 10 years, I've been with Azelio, where we have developed this long duration energy storage technology. Thank you.
Thanks, Jonas. And last but certainly not least, Julia Souder is with us. Hi, Julia. Good morning.
Hi, Christina. Good morning. And thank you so much for the opportunity to be here today. Hello, everyone. Welcome. Really excited to talk about long duration storage. I'm Julia Souder. I'm the executive director of the LDES Council. We are based in Brussels, and we're a new global secretariat that we'll find out a little bit more about, but just thrilled that we're all talking about long duration storage. And I've been in energy environment for over 20 years.
Perfect. Well, thank you, Julia. Only 20 years, huh? Just kidding. Well, thank you, everyone. And thank you, everyone, for using the chat. We have people from all around the world, Lisbon, Tennessee, Chile, Canada. So it's great to see everyone here. And without further ado, I think we're going to start with the presentations. I'm going to stop sharing my screen to let Omar share yours. So whenever you're ready.
Yep.
And remember, everyone, in the meantime, if you have any questions, you have that section to ask any questions you would like to the speakers.
Are you able to see the presentation?
Perfect.
Perfect. Thank you very much, Christina. So what I am going to do is to present kind of really short, high-level overview of energy storage for grid applications in view of high-level penetrations of wind and solar PV in the power system. So in this diagram here, you can see a summary of different applications for energy storage in the grid, and also the time scale of each of those applications. For example, the typical application, we have energy and firm capacity supply, but there are also a bunch of different additional applications, for example, frequency, voltage regulation, ramping reserves, etc. And in addition to that, something that for me is kind of very interesting is the time scale of those applications, right? Like ranging from milliseconds to seconds to minutes to hours to days, months, and years, right? So there is a variety of applications for energy storage in the grid, and also the temporal scale is, diverse. So this is good to keep in mind, right? It is not only about energy shifting, it is also about, different applications, for example, frequency, voltage regulation, ramping reserves, etc. In addition to that, we know the mismatch between load and generation from wind and solar PV resources also occurs beyond the intraday time scale, right? We used to think about, lithium-ion batteries for solar PV integration, but the fact is that when you keep increasing the wind and solar penetrations in the system, then you're going to face more mismatch beyond the intraday time scale. And this includes intraday as well as seasonal time scale, right? So indeed, for very high penetrations of wind and solar, we're going to need a combination of short duration, long duration, and seasonal energy storage. And this is going to depend on the system, right? Like there is not going to be a unique solution that is applicable everywhere, right? There is going to be a different optimal solution for different cases or different locations. For example, wind-driven system versus solar PV-driven systems. And in this summary here, what I would like to do is to present kind of high-level overview of the key aspects of energy storage. First, energy storage technology could facilitate the integration of wind and solar PV power sources into the power system. However, the quantification of the required energy storage deployment in view of high renewable power system is a challenge, right? Like today, we don't have the tool to do a holistic or comprehensive modeling of multi-scale energy storage technologies for solar PV and wind power integration in the system. Also, the scalability of energy storage technology is important for industrial application, right? Yes, efficiency is good. Yes, cost is good. But what happens when you scale that technology, right? Moving from, let's say, kilowatt to megawatt or to gigawatts. Do you have, constraints on the use of critical materials? Do you have siting constraints, for example, for pumped hydro energy storage or for hydrogen energy storage or for compressed air energy storage? Those constraints could, limit the deployment of a specific technology. And finally, testing and validation of energy storage technology for applications beyond energy shifting is critical in my opinion. For example, testing and validation of energy storage for reliability and resiliency applications, or for, let's say, 24/7 renewable power supply, because we know that the storage could provide more than just energy shifting. So it is important to test and validate those technologies for these new, or let's say, different applications. Thank you very much, Christina.
Thank you, Omar, for sharing those facts with us. And now we're going to Chris Connor's presentation. It's going to tell us a little bit about Breeze and what they're doing. Great example of long duration storage. So Chris, whenever you're ready.
Okay, can everyone see my screen?
Perfect.
So I'm here to talk about Breeze today. Breeze's solution is called a compressed air pipeline system, or CAPS for short. It is a distributed long duration energy storage solution. Here's a quick overview of how it works. To the left, we have renewable energies producing electricity that runs compressors. The compressors generate, compress the air and place it in a pipeline. Energy is stored there until it's needed. When it's needed, the process is reversed. The air is released at up to 700 pounds per square inch, is thrust upon turbines that generate electricity that then gets fed to the grid as needed. So there's about 3 million miles of pipeline in the United States alone, and about 25% of those pipelines are idle. To the right is one of the pipelines that we're looking to use. It is a 34-inch diameter pipeline and is 1,100 miles long. That's called a main pipeline because of the size of it, the capacity of it. There are 125,000 miles of main pipelines that are currently idle. And if all those pipelines are used for CAP solutions, it'd be able to store 500 gigawatt hours of energy at any given time. If all those pipelines eventually become idle, that would be 2,000 gigawatt hours of energy capacity. So obviously, this is a long duration energy storage solution. We're able to store weeks of inertia energy for months, but it's also a transport solution or transmission solution, because fossil fuel pipelines are designed to transport fossil fuels from one point to a distant other point. And so it travels many miles, like the previous pipeline was 1,100 miles long. But with that being said, why not use the whole pipeline It ends up there's grid connections all along the pipeline, and we could have intake and offtake locations throughout all across that pipeline through remote areas, connect solar and wind fields and farms, as well as connecting urban areas and releasing and expanding the area there. And if you're building multiple locations, intake and offtake locations all along the pipeline, that means we can simultaneously charge and discharge at the same time. There will not be a cycling factor like batteries. Also, because you can have multiple off-taking locations for a black start, you could have all of them generating electricity at the same time, providing a huge amount of inertial energy capacity at one time. Finally, one of the more important aspects is this is ready to build now, and it's available now. There requires very minimal amount of disruption to the infrastructure. The pipelines are already in the ground. There are usually grid access, grid connections to those pipelines as well, that they may need increased capacity, but it's there. We're using off-the-shelf equipment. Well, what they call off-the-shelf equipment is commercially available, compressors, heat sink, as well as expanders. So this solution can be developed, put out there right now, and is. Some metrics on performance. We can store vast amounts of energy with very little degradation. Our round trip efficiency is almost 70%, and we expect to be able to get it higher. This solution is very safe. Most of the pipelines underground. So if there's a leak, we're leaking air underground. And finally, this can be a 100% renewable solution. You don't need renewable energy for this. I want to give you a couple of projects to give you a little idea of what it can look like. On the right-hand side is a smaller project in blue. This is really a shoulder solution to be able to provide energy from 3 to 7 o'clock in the evening where they need an extra boost of energy. It's a smaller pipeline. It's a 35-mile segment and is 18 inches in diameter. It'll have a 5 megawatt storage energy capacity and a 30 megawatt hour storage capacity. It'll cost $15 million to build it. Its payback period is 5.5 years. With the new IRA tax credit, the payback period on this is less than 3 years. To the left is a utility scale project that we're looking at using that same pipeline that we showed you before. It's 195 miles of that 34-inch diameter pipeline. It will have a 27 megawatt power capacity, 694 megawatt hours of energy storage. It'll cost $52 million to build this solution. Its payback period is 22 months. And with the investment tax credit, it's less than 1 year. So money matters. And that's why I wanted to show you some comparisons of the energy, because this is the Lazard's unsubsidized levelized cost of energy comparison. In the circled areas are our renewable energy. The top circle is solar, utility scale solar, and then below it is wind. And then the 4 areas down, 4 bottom lines are your conventional energy solutions now: gas peaking, nuclear, coal, and gas combine. And you'll notice that the renewables, the solar and wind, are lower cost than the conventional systems. The reason why I'm raising this is we realize that at some point we're going to have to add storage into the formula, but there is some headroom in between the two of them. So I think what this panel, part of what the panel is going to discuss today is how much, when, and how much will it change that metric of cost. And I suspect it's going to be less than the conventionals. My name is Chris Connors. I'm with Breeze. I look forward to the panel discussions. Thank you.
Thank you, Chris, for showcasing the solution. Amazing. Next, we have Jonas Wallmander from Azelio. Jonas, whenever you're ready.
Thank you. Let's see, share my screen. So can you please see my screen now?
I think it's, you need, there you go.
So great. I think that there are two things that Omar put it very right. We need more just than a couple of hours storage to support the power system. We need intraday and we need seasonal. And also Chris was very sort of correct and right when he said that PV and wind are now cheaper than all the other sources of energy. And the solution to solve this is, of course, to add more storage to the system. And Azelio, we have a very unique and game-changing long-duration energy storage solution. And just as mentioned, solar and wind energy are only available when the sun shines and the wind blows. We all know that. But if we are combining our Azelio system with PV, we create a base load that can really power the 24 hours of the day and outperforming any available alternatives when it comes to cost per kilowatt hour. And this technology is already today commercial and in operations. And we have already performance sort of third-party verification of the technology that it performs according to the specifications. Let's see. So the Azelio solution is we are at this moment focusing like behind the meter for the C and I segment. We are the solution when it comes to like weak grids, off-grid, and unreliable grids at this moment. And we have seen a huge interest and also traction in the agriculture segment for solutions such as poultry farming, greenhouses, food processing. And there are also other sort of large markets that is coming right now, because, for example, if we want to have trucks that are run on lithium-ion batteries, we will need truck charging stations along the intercontinental highways. To solve this, you need long-duration energy storage combined with local production, because it's just too expensive to build infrastructure and all these stations. So that's why you need both short duration and long duration storage close and production of renewable energy close to these charging stations. We'll also see the need in remote communities, because the cost of the same thing, the cost of building infrastructure to these communities is just too high. So combining solar PV and long duration energy storage, then we have a much cheaper solutions for these remote communities. Because the challenge that we solve is that we are cost efficient already in small scale, from 0.1 megawatts and upwards. And we have this possibility to close the 24-hour cycle, combining our technology and solar PV. So it's both cost efficient, scalable, from small to large, and suitable for distributed use. And this is very much in line with the solar PV installations that have the same side of distributed sort of setup. Let's see if we... So how does it work? So in general, it is charged with electricity from example, renewable energy sources as wind or PV. And then we are melting aluminium, and we are using the phase change of the aluminium. So by that, we can store a lot of energy in a very small volume. And then we have a heat engine that transforms the heat back into electricity. But we can also, by using the heat engine, produce heat for like process industries or similar use. So it really works like a battery, but it's not a battery. And there are some things that are really sort of different from normal batteries. One of them is that it's 100% depth of discharge with no degradation, since this is based on physics. We're only using commonly available materials. This product is made mainly of steel and aluminium. And it can also be fully charged in half the time it's discharged. So the discharge time is 13 hours full power, and we can charge it in only 6 hours. And this, of course, delivers both electricity and heat. And today, if we install these systems, when we install these systems, it is 40% lower in the cost of energy production if you compared to building the same type of system with lithium-ion batteries. And keep in mind that this technology roadmap has just started for this product. And there are many cost and efficiency improvements in the pipeline for the future. So where are we right now? We have the first commercial products installed and in operations. So this is really my highlight projects. First of all, our first project that we sold a couple of years ago. This is in the MBR solar park in Dubai. This is an off-grid system for a commercial building. And it's been in operations since Q3 2022. We have a product in Egypt that we are installing the first half of 2023. This is a super interesting product that was launched on the COP27. And we are in this project combining our technology with solar PV and with a desalination plant. So that we are able to produce desalinated water for farmers in the desert. We have in South Africa an agriculture farm, poultry farming, that started this quarter this year. And we have sold a product for a commercial building in California in the US. And we'll use this project to certify the technology for the US markets. So we're really now taking the first step out with the commercial rollout of this technology. So I really look forward to this journey, and we've been working quite hard for many years to put this product on the market. So I just want to say thank you, and please contact me if you're interested in these kind of products with us. Thank you.
Thank you, Jonas, for making this technology more tangible. Last but certainly not least, we have Julia. Julia, whenever you're ready, you can share your presentation with us. You're on mute at the moment, just so you know.
Yes, thank you. It's frozen. Hopefully this is working now. My computer just froze. Classic.
You're fine.
Great.
In the
Got
okay.
it?
Yeah,
okay,
perfect.
Wonderful. And I also, again, thank you for the opportunity to be here today. And I'm Julia Souder, the Executive Director of the Long Duration Energy Storage Council. And want to just say thank you to the panel, because it's a really important topic where we're building this foundation, where Omar really laid out the importance of storage and how critical it is to justify, meeting every hour of every day with clean energy, and how you can do that, especially with long duration energy storage, and giving you the data to really validate the needs, is building this foundation, and really then seeing projects that are, working in the ground, that are out there, increasing the knowledge and awareness of the diversity of types of long duration energy storage is really important. So looking forward to the dialogue today. Really wanted to give a background about why this is so important. As we all work together to make this transition to meeting our global net zero targets, we really need to look at the entire ecosystem. And so we're looking at the importance of power, heat, and hydrogen, and how we're having to move to climate dependent renewable energy. And with that variability, you need some flexibility. And that's what long duration energy storage can really provide. So you're getting that with really bringing this whole ecosystem together with long duration energy storage, the multi-hour, the multi-day, the monthly, and then the seasonal. So all those attributes can really kind of bring that infrastructure component where you get that resiliency that we need. So really just wanted to highlight again, just this nexus that we're all working towards of how critical long duration energy storage is and how important these different elements are. And so when the council was launched at COP26, we had our flagship net zero power report, and our members came together to really promote this unique perspective of not only having the diversity of the 4 different types of long duration energy storage, the chemical, thermal, electrochemical, and mechanical, but also the fact that customers really want to buy and invest in long duration energy storage. So you have capital providers, equipment manufacturers, developers, all coming together to really build this partnership and validate this $4 trillion marketplace. and how important this is to meet our 2040 targets. I mean, every year it seems like announcements kind of come from 2050, 2040, 2035. So we have to work together to really kind of excel this marketplace. And that's what the council is doing for society's benefits, giving factual information to start really changing the infrastructure so that we can have this marketplace that really does give this value add as we transition to clean energy. And what's really exciting is that we grew from 22 members to over 65, and that we are covering over 20 countries and growing. And we are a year old. So we look forward to the many years to come and the duration in front of us of being in partnership with many different organizations and communities. And so one thing that we're doing as a membership, we have all these different working groups. And so in 2022, we really kind of wanted to have discussions over this flagship report and really having this conversation of how important net zero power is and the role of long-duration energy storage, but also wanted to give some various tools, whether it's a 24/7 clean power purchase agreement, really evolving the fact that you can actually track every hour of every day, of every month, of every year, and making sure that those hours are met with clean energy because you have long-duration energy storage on the grid or in your heat and industry. And so that's really important that you really can demonstrate and give that transparency to moving away from fossil fuels. And we have partners like mining organizations and companies that have traditionally used fossil fuels who are very aware of this transition and working with us to how do we build these remote grid systems? How do we use existing infrastructure that Chris outlined and the remote systems that Jonas was speaking to? How do we make this transition happen? And how do we optimize and use storage as a transmission asset? How do we use, look at this cost savings of thermal energy storage? What are some different policies that we can do to adapt to change to create this new marketplace? And what's the data again and the benchmarking to really show that there's a lot of information out there to build that need, and giving a marketplace, and then also focusing on various countries. And there are a lot of great initiatives and announcements that have been made in just the last year of increasing storage targets. And we want to continue to build that momentum, and make it from 1 gigawatt to 10 gigawatts to 40 gigawatts to the 8 terawatts that we need of long duration energy storage. So we look forward to working with all of you to start implementing these big, significant changes that make all of our lives better. And so in the last year, our members we've been really busy with our knowledge partner, McKinsey, and we had our flagship report that we published at COP26. And then we built upon that, this 24/7 clean power purchase agreement, really being able to track, when you have 60% integration renewable energy on the grid or in your system, when you have long duration energy storage to maximize the value, cost savings drop. I mean, you have cost savings where you get 60% savings, you have prices, the affordability, like everything comes to life. And so really again, showing that significant partnership of long duration energy storage. And again, using this metric to validate that you're meeting your ESG targets, that you're actually showing that you're making this transition. That's much more than just a certificate program. So building on that really important toolkit, adapting current PPAs and evolving them, we looked at the variety of policies. And so we are not a lobbying organization, but we do really work hard to educate and bring awareness to the importance of long duration energy storage. And I'll speak to kind of the 3 different overarching themes and the 20 different recommendations that we worked on that you could adapt globally again. And this could definitely be in your backyard of how do you bring in either a large scale long duration energy storage or a small scale remote on-grid power, heat, hydrogen. Again, that diversity is really important. And at COP27, at our year anniversary, we were thrilled to launch our net zero heat report. So building on the benchmarking that we did the year earlier, showing the expansiveness of just the marketplace even growing bigger because of the demand of wind and solar, and really showing this $4 trillion marketplace, that 8 terawatts of energy that's needed. And again, showing that how we're going to accelerate decarbonization and the important role of thermal energy storage and the savings that are involved. I'll show you in another slide just how much money you can save annually by having thermal energy storage really kind of incorporated into your system. And so we've continued these conversations. We have a lot of recommendations, and we look forward to working with our memberships and partners on implementing all these key factors. With the various, the European Union has announced a lot of great storage goals going forward. The United States and their IRA package and the incentives that Chris noted, and Australia has recent announcements on their targets. So this is all really great momentum to kind of build on why it's so important to send these long-term market signals. We need this procurement targets. We need this information out there to keep pushing the market forward. And again, it's showing that ecosystem. How does solar and wind work with storage? How do we really have this package deal to give you those cost savings? In addition, there's revenue mechanisms, having these grants, incentives, the public-private partnerships to really deploy are critical. Building on the 24/7 Clean PPA tool, there are other tools out there with, capacity market expansions, with different types of LMP pricing, different certificates. We don't have to reinvent the wheel. We can make the wheel better and more inclusive to make sure we get all the benefits of long duration energy storage. And building this, the grid planning and this better direct technology support. The market rules. There's a lot of conversation about this new awareness and how to make the adaptations so that you don't just get the great benefits of just charging storage, but you also get all these ancillary services and credit adds. So how do we change the criteria and adapt it to really enable all of the benefits and savings and affordability that you get from long duration energy storage? And so just really want to highlight again, the most recent report that we did highlighted the important value of, power and heat and how important thermal energy storage is to the equation, because the industrial sector is almost 50% of the emissions. And how do we need to, abate that and change it? You need long duration energy storage. And so as we're really trying to address decreasing emissions and fighting climate change, we need to also show, the benefits and the cost savings. So, there's over 90% system efficiency when you have, the right setup with thermal energy storage, and just the rate of return and how much you can actually get on your investment because of the enormous value add and the cost savings. I mean, just the marketplace for long duration energy storage is enormous. And the fact that we really again have to have these partnerships to really amplify the benefits of renewable energy and really make sure, again, it's at every hour, every day. It's a $4 trillion market. So there's so much opportunity and so much diversity that's available. We're not trying to fight over a piece of pie. We're trying to make the pie bigger for everyone so that we have, a really important way of addressing all of our needs. And something that you don't always hear about, but it's so important too, is this affordability. The fact that you can have $540 billion annually saved with long duration energy storage is a large number. And so not only do you get cost savings of having lower prices because of the storage and renewable energy package, but you're also getting these annual savings. And so again, it's just really important to kind of look at this entire nexus and ecosystem of the value out of long duration energy storage with resiliency, security, reliability, affordability. And also, again, the fact that you have this diversity and flexibility to meet that energy shifting that's happening on our power and heat systems. And again, as we look at partnerships with renewable energy, where does, clean hydrogen play, and how does that part, role with long duration energy storage grow? So we thank you again for the discussion and the opportunity to work with all of you, and look forward to the questions, because there's so much going on in the LDES world and growing partnerships. And thanks again for the opportunity.
Definitely. Julia, thank you so much for taking us to the evolution of the LDES Council. In 1 year, you guys have done an amazing growth. I can't wait to see what's going to happen in COP28.
Okay. You kind of manage those expectations. But one thing that we're really excited about is that, this ecosystem, really looking at the entire infrastructure. What does this net zero package look like when you have, both small scale, large scale, remote systems, and just really kind of showing, again, the importance of how long duration energy storage can play a role in all these sectors. And we formed an MOU called the Global Renewables Alliance. So there is a now global pact among Long Duration Energy Storage Council, Global Solar, Global Wind, the International Hydropower, and Green Hydrogen, and International Geothermal. So you have all of our organizations coming together saying, we have to work together because we have to really start working hard to make sure our marketplace does really have that diversity to make all of us do our jobs to really meet our net zero targets. So this Global Renewable Alliance MOU is a huge deal that we look forward to working with our members and our partners on implementing. That's one of the many things.
One of the many things, definitely. Well, thank you so much for giving us that explanation. And thank you everyone for I'm seeing that questions are coming up, that there's tons of questions. We have a couple of pre-submitted questions in the meantime while we get more questions from the audience. So I have a first question for Omar, which is about the levelized cost of storage. Do you think it's an appropriate metric for the assessment of energy storage? And please, the rest of the panelists are free to chime in if they want.
Thank you very much, Christina, for the question. A very, very relevant question. You know, when you look for a storage, LDES is one of those metrics that show up first. But I think we need to move beyond that metric, because that metric is focused just on the cost. And, you know, if you are going to make an economic decision, right, like, do I invest in this specific technology for this specific application? You're going to be looking not only at the cost, but also the benefit, right? Like, why are you installing that technology in that specific location for that specific application? Because there are some benefits associated with that technology. So we need metrics that really capture also those benefits. And those benefits, you know, goes beyond just energy shifting. For example, for reliability applications, right? Like when you move from 10 to 15 hours, the benefits are different. Right? If you have a technology, for example, that is more flexible, that produce maybe, you know, in addition to power, you are able to produce heat, and you have heat demand in that specific location, then you get the additional benefit. So those metrics, like the ideal metric, I would say, need to capture those additional benefits and be more kind of general to capture not only cost of the technology, but also the benefits associated with the specific application and the specific location and the specific technology. I am not sure if someone else wants to say something about this question. I don't want to do kind of monopoly here.
Omar, you're great points. Jonas, do you want to say something and I can jump in?
I mean, cost will always be maybe the most important metric, but there are also so many sort of, as you say, things that you can do with long duration energy storage. For example, in the installations and in the projects that we have in South Africa, they have such a big problem with the grid, and they have these load sheddings daily on up like 6-12 hours sometimes. And just to get rid of that problem with long duration energy storage combined with solar PV, that's a huge benefit for these clients, because they run on diesel all this 6 or 12 hours daily. And so there are definitely, but also alternative costs that has to be taken into the picture, and sort of production losses and stuff like that. Because if you have your production of energy close to your own production, if you have a like industry, the risk of having production losses is so much less than if you have a huge or unreliable grid.
And one thing I would just add to Omar's point, you know, it's great that we have LCOS, and then we also have levelized cost of heat, and we're using these metrics, but again, they could be improved. So we're working with labs and working with other organizations on how to add to the criteria, so that it's not just 2 or 3 different level rows of this is what long duration is, but really tracking the ancillary service that can be provided. Are you really looking at the load following and the frequency and the black start capabilities? Like, are they getting credit here? And that's also part of the entire cost value add equation. And then what's the environmental, components, the land use and emissions reductions. Again, the carbon pricing would also just change the dialogue. And then I think, again, the diversity within batteries themselves, there's so many different types of batteries that could have that, element of looking at different categories. So I think we need to do some more advanced work on improving the criteria from the modeling, but also then for the procurement, just to really make sure that the entities, utilities, the different customers involved are getting all the different benefits that are available with long duration energy storage.
Thank you, Julia. Jonas, you are not muted. Is there anything else you would like to add?
No.
Okay. All right, well, moving on. We have a question for Chris and Jonas from NREL. It says, remote communities need renewable and storage, but may not be accessible by conventional means. Can either of you speak to the local skill training within the communities where such projects are deployed?
So Jonas could probably talk about being deployed. We have some on the planning books right now, particularly, our pipelines go through lots of remote areas by design, but connect a lot of urban areas at the same time. And as we build it out as a power highway, energy highway, we plan having stations all along the way that'll have to be serviced by the local community, but also will provide them energy. One such examples we have a solution being planned for Indian reservations, indigenous people reservation, where right now they don't have energy all along across their reservation. So this will provide them with energy resilience, microgrid, but that they can build an industry out of, because they have a consistent level of energy for them, but also they have to maintain it, right? So there's jobs involved with that, but it's also a job creator. Jonas, you.
Yeah, I can sort of confirm that, for example, in the project we have in South Africa, we have now a training program for the operators and the ones doing the maintenance or the daily maintenance, sort of checking things and stuff like that on the farm, and it works very well. I don't think that, so what is a remote community? If we talk about sort of remote African villages, it will take a while until we have the sort of right training for the staff for these kind of applications, because you need some kind of sort of knowledge of how to use sort of control, just as any, if you have a microgrid with DC gensets or whatever, you need some kind of skills. So it's, I don't think that at this stage we can see that the African villages is, at least for us, our customers, but for sure, like in the US, in South Africa, it's easy to find people that has, if they have been working with engines, they can work with our engines. So that's how easy it is, sort of. But you need some kind of skills and some experience in mechanics or electronics.
Absolutely. Definitely. Well, thank you. All right. Well, we have a problem. We have a lot of questions and they're really interesting, all of them. So I don't know if we can, if we have enough time for that. But however, we'll do our best. So the next question is from Deborah Murphy. She says, given the interconnection queue backlog, PJM, MISO, of new renewable and storage projects, is long duration energy storage have to be 100% behind the meter only viable, or is it only to help with the utility transmission grid? How can we get the long duration storage implementation happen in the next 5 years, given the interconnection queue backlog?
Deborah, great question. And this is a global concern. This is happening around the world. There are issues in almost every country where they have a large infrastructure grid where there's interconnection queue problems. And so this is something that we're working as a council to really start to address, because you can have behind the meter, off the grid LDES, which could really help fix today, but you also have a lot of the hybrid or co-located products that might even be large scale. So that diversity is also really important. I think what's exciting to see is that, as we noted, inclusive grid planning is so important. So as different ISOs, RTOs in the US work to, look at the data sets and the grid planning for the next 5 to 10 years, how can we actually really bring in criteria today to actually look at co-branded, co-hybrid, be creative about different facilities, or even just give existing upgrades that could happen. So there are ongoing discussions that are needed. We need to kind of continue to push policies and have state support and federal support to really kind of make sure this is amplified. But I'd say, again, this is a global problem, a global concern that everyone's trying to find creative solutions to. And, we're working on this. Also, the fact that, inclusive grid planning is really important, and really making sure that there's more data, and the criteria is out there to really kind of show that these can be solved. And again, having that flexibility of knowing that this diversity of long duration energy storage exists using existing infrastructure. You can take an existing gas plant and move it into a long duration energy storage technology. There are many different types that can, really kind of transform and even take the working, the workers there to really kind of have part of the transition. So there are a lot of different formulas. It's really being aware of what's available, and then working with the labs, DOE, and other groups and regulatory arms to really kind of continue to push the momentum and the force of why this is so critical. But yes, storage as a transmission asset is possible. Even storage as a generation asset is possible. So I think it's just knowing how we can alter the criteria to make sure that we're meeting and getting the best out of LDES.
Just a supplemental to what Julia said is, obviously our solution is also transport. We don't view us as taking over the transmission grid, but as a supplement to it or an alternative when needed. But energy storage by itself optimizes the grid, can help optimize the grid. And so if you start thinking about you have wind turbines that are out there spinning during the day and can't generate electricity because they can't get capacity on the transmission, they can plane that out by storing it. We have to be smart in understanding, planning out our storage where it can be the most use when it's needed.
Great point, Chris. The entire ecosystem. Yes, not trying to silo it off. Omar.
Yeah, just a comment. I think in general, right, like the optimal solution is going to be a combination. We are going to have grid scale long duration storage devices connected, and in some cases you may have also behind the meter, long duration storage for a given application that maybe requires significant reliability or resiliency, for example. So I think it's not 100% versus zero problem. I think it's more about a mix, right? How much is going to be the mix is going to depend on the specific case.
Okay, well, thank you. Our next question is from Jose Alfonso Nebrera, and this has come up in a couple of conversations that I have, which I think is very important to clarify. How long is long duration? Exactly. No, I think it's an open conversation, but do we have a range? What should we start considering long duration? And also, what about seasonal storage?
I would like to say something about it. This is a very interesting question, very complex question, and I just put a report from Paul Denhol about this topic. It's really difficult to define, long duration seasonal storage. There is not a, proper definition. It depends on the specific system, the specific metric that you use, right? But in general, right, we used to think that, short duration is below 10 hours of duration, then long duration between 10 and 100 hours, and then beyond 100 hours of duration, you have seasonal storage. But that definition is gonna, it depends. There are different criteria to define those boundaries, right, between let's say, short duration, long duration, and seasonal storage. And I think that report is, a really interesting report in that sense that explains, the different metrics that could be used to define long duration storage. Thank you.
And to build on Omar's point, as the authoritative voice on long duration storage globally, we have defined it in our reports, and we show that there are these three categories. So, the 8 hour plus is the sweet spot, but that 10 hour plus for multi-hour, multi-day, and seasonal. So you'll see us in the benchmarking that we did, look at the 8 hour plus the 24, then the 24 to the 100, and then the plus 100 and the 150. So you can see us block it off and show that the importance of long duration storage is the fact that you have the 4 different types. So you have the thermal, electrochemical, chemical, and mechanical. And then within that, you have the hour blocks. So it's a lovely math equation of then you have the 3 categories of the multi-hour, multi-day, and seasonal. And so you'll see it in the benchmarking that we allocated, that we really did highlight, there is this diversity that's needed, but yes, we've been able to define it. Okay, well, thank you so much for that explanation. The next question goes to Chris from Yeldad Yezbolov. He asks, what is the pressure rate for the system, and what is the capacity of the pressure vessels?
Okay, so really good question. Most of the vessels are rated to 100 bar roughly, which is 1440 PSI or 1450 PSI. We are operating at a lower level than that. And there's a couple of reasons, but both of them are economic. One's a long-term economic, one's short-term. One is it's more efficient to operate around the 500 to a max of 700 because it costs less to compress. So it raises our round-trip efficiency. And right now we're cost sensitive in what we're providing to our customers, and we have adequate capacity so we can do that. The second reason is the higher you go up in your compression levels inside the pipeline, it causes pipeline fatigue. And keep in mind, we're reusing existing pipelines that have been around for 20, 30 years. If we operate no higher than 7 and approximately around 500, that pipeline can last another 50 years. But as soon as you start pressing up into higher levels, the life of that pipeline goes down quickly, and the likelihood of a leak increases as well. It's wear and tear. So it's a balance of what we're trying to operate in from both an economic perspective, short-term and long-term. I hope I answered this question on that.
Perfect. Thank you, Chris. Next question we have from Shiva Venkat. This question is for Julia. Julia, how do you be part of the LDES Council? What do we have to do?
And I just sent a note too. So
Okay.
and it was great that both Jonas and Chris are members of the LDES Council. And so we're thrilled to have them. And there is an application process. I'd be more than happy to set up a call to go through our membership packet with you over the phone. But we are really thrilled that we have 3 different categories of technology providers, service providers, and anchor members. So I'd love to work with you offline, but there's a process. And once we and look forward to having more members join us.
Okay. Well, thank you. All right, we have a next question from Chuck Kutzer, asking the following. As we properly electrify buildings with heat pumps, many summer peaking U.S. utilities will become winter peaking. Given that winter days are shorter and have lower solar output, how much and what type of storage will we need to handle very cold, windless periods in the winter when heat pump cups are low and auxiliary electric? Omar.
Yeah.
Okay.
Yeah, I can say something about it. When you move from summer to winter peaking problem, right? What you are making is the seasonal aspect of energy storage or energy shifting more like complicated a little bit. So what I think is going to happen is that you're going to need more kind of long duration and seasonal storage, let's say across multi-month shifting of VRE surplus from summer to winter. That is going to depend also on the type of system, right? For example, if you have a solar PV driven system like in CAISO, that is going to be different than in MISO, where you have a wind driven system with different shape of power generation. So I think it's going to depend on the system, but in general, moving from summer to winter peaking systems, you're going to see a transition from, more like long duration and seasonal energy storage, given the fact that, now you have a winter peaker system in which you don't have enough, let's say, solar or wind during those periods.
And Christine, if I could jump in too, because Omar makes some really good points that we need to look at the seasonal attributes that long duration energy storage can provide, really capturing solar in summer and using it for heat in winter. And we just published a report on this, our net zero heat report, where we really talk about different types of options, whether it's district heating, different types of thermal energy storage, whether it's volcanic rock, whether it's bricks, concrete, salts, there's a whole different a lot of pathways and options that are actually commercialized today that are being used around the world. And so, we're really, there's, also showing that you can have a range of degrees. So in the report, we highlight 5 different archetypes looking at, a couple 100 degrees Celsius to 2000 degrees Celsius. So then, having that range, not just for industry, whether it's refineries, but also for district heating or wastewater management or sewage. So really being able to capture in a variety of ways, this flexibility so that you can really capture whether it's one season to the other season, whether it's month to month. But again, you have the optionality of long duration energy storage giving you those seasonal attributes, which is really important. I'll put the report in the chat.
Okay, thank you, Julia. Next question is from Eric Watson. He asks, what are the commercial and technology risks of storage proposals evaluated by financial institutions, and how do we mitigate these risks?
Great question, and one that we've been having a lot with financial institutions, banks around the world, insurance organizations, and that's why we created service provider membership, because a lot of traditional banks are now starting to really address the fact that they can feel that valley of death because they want to help fund. They realize that LDES is de-risking the transition. And so now we're really trying to look at different types of equations where whether it's recent funds by BlackRock with $700 million, where there's a huge component for long duration energy storage, where there's a lot of different equity groups that are really starting to fund a lot of our member companies and get them from Series A to Series D to F and really kind of get them to the commercialization to scale up. So it's phenomenal that the conversation has changed. I think a couple of years ago, there was a lot of entities way on the sidelines, but that has changed. And now we're really trying to see this market evolve and the diversity of investors come forward. So it's exciting to see not just, a lot of VCs or equity firms, but also traditional banks and other groups now step up, and because they are validating and justifying the need.
But still, I just want to comment that it's still that you need runtime data. You have to prove your technology. You need this verification report from like Lloyd's, DNV, and so on, to sort of show that you have something that is viable that you can put on the market. So I think that's still the basics.
Yep,
because
gotta prove it.
you never get any insurance company or bank to sort of lend money without having these kind of reports.
Great.
Okay. Well, thank you. Well, next question we have from Patrick Vera. He says, question for all, just so you know. Once long and seasonal storage is commercialized and implemented, what is the role of short duration for a market like the UK or Australia or even the US, I would also add?
I think there's always going to be part of that ecosystem, a place for short-term solutions as well as long-term solutions. And a lot of our long-term solutions aren't particularly effective at the short-term solution model. So they're very good at doing the long duration and a set capacity, but they don't have that quick localized effect that you can have with a battery or another short solution perspective. So there's no one right solution. What we found out in the long duration energy storage solution is it's really about us putting it all together with all of our different technologies and our different roadmaps of where we're going to put together a full solution for what's going to be needed in the environment.
Yeah, just an additional comment on that aspect, Chris. I think it also depends on the specific technology, right? For example, you have a lithium-ion battery or a given battery for short duration storage that may degrade if you keep, ramping up and down quickly. Then you need to impose that constraint for the operation, right? So then, long duration could play a role also in the intraday shifting of VRE surplus if you have constraint for the cycling of the short duration storage technology. So there is going to be, an ecosystem, and there is going to be an optimal way to operate that ecosystem, including, just intraday energy system plus interday and seasonal shifting of that VRE surplus, and also, to provide different services to the grid, like frequency, voltage regulation. So we need to make that combination and optimize those technologies in view of the system needs.
Yep, I can comment. I mean, we've been building off-grid systems, and in our off-grid systems, we have our solution. We have lithium-ion batteries, a small lithium-ion battery for frequency control, because lithium-ion batteries are really, really good in frequency control. And then we have the PV, and we also have as a backup a DC genset. I mean, that is sort of just the infrastructure we need when we build off-grid solutions. So there's definitely a need for short duration also in the future.
Okay, well, thank you, everyone. We're almost out of time, unfortunately. This was the problem, actually. But thank you, everyone, for such amazing questions. And thank you to our speakers. Thank you for showing us a bit more about long duration energy storage and getting it closer. So it's definitely the time to start looking more into it. And if you have any further questions, let us know. We will send the materials shortly. And if you have any further questions, we're here to help you, and we will see everyone in our next RedMad webinars to have great speakers as the ones we have had today. So Omar, Jonas, Chris, and Julia, thank you so much. If you would like to say any final remarks, this is now your time.
No, maybe just to say thank you to everybody for the question, and Cristina for the opportunity to talk about this very interesting topic. And, we need to think ahead of the problem, right? Like, we need to develop those technologies before we need it. And that is the reason why we're having those webinars, right? Because those technologies are going to be needed, and we need to talk, in advance about it, and, having this holistic view of benefit, cost, implications, etc. Thank you.
I'd also like to thank the audience. Your question shows that people are becoming very well aware of long duration energy storage. These are better questions than I normally get, so it was a great opportunity to be on this panel. Thank you.
Yeah, I just, also Chris, thank you. Great questions and really good panels. So thank you all, everybody in the panel also. I think the discussions were really good. Thank you.
Thank you all. Thank you, Christina, and thank you to Omar and Chris and Jonas. It's always great to work with you. And I like Omar saying that, this is an ongoing conversation. We're all motivated. We have to make a difference. Long duration energy storage is part of the solution, and that we're going to continue to work on this to make sure we capture the marketplace and make sure that we get all the benefits with the partnerships available for LDES. So thank you all so much, and happy holidays. Great questions.
Thank you, everyone. And please stay tuned for more about LDES, because there is going to be more to come. So everyone, have a wonderful day. As Julia said, happy holidays, and